From 6 different novels and 3 different dictionaries, 4 novels and 1 dictionary are to be selected and arranged in a row on a shelf so that the dictionary is always in the middle. The number of such arrangements is option 1 at least 1000, option B less than 500, option 3 at least 500 but less than 750, option 4 at least 750 but less than 1000. So it is very clear that the question wants you to first select. What you have to select? You have to select from four novels from 6 distinct novels and 1 dictionary from 3 distinct dictionaries. So it is very clear that we have to apply selection technique, and 2 selections are done in stages as the and word indicates. Now what you have to do in the second act, then it wants you to shuffle the selected thing. So if you have selected 4 novels and 1 dictionary, that needs to be shuffled, but there is one condition, and the condition says that dictionary need to be kept in the middle. So we have to simply apply shuffle technique, but first we have to place the dictionary in the middle. So concluding, this question contains clear instructions, thus you must follow what the question wants you to do in the same sequence. So coming to the second part, we have to do the detailed analysis. So as it is very clear that we have to select 4 novels and 1 dictionary. How we are going to select 4 novels? We have to select 4 novels from 6 distinct novels. It means the answer would be 6C4. Now as the word is and, so and would be replaced by multiplication, and we have to select 1 dictionary from 3 distinct dictionary, so it would be 3C1. So it is going to be, the selection procedure would be done in 15 into 3, that is 45 ways. Now then shuffling, we have to shuffle, but there is one condition, that we have to put the dictionary in the middle. So first we'll place the dictionary in the middle, and then we'll be getting 2 places on the left side of the dictionary and 2 places on the right side. So basically we'll be shuffling 4 novels in this 4 slots, 2 slots on the left and 2 slots on the right of the dictionary. So the shuffling of the 4 novels at 4 slots would be done in 4 factorial ways, that is 24. Both the acts are done in stages, therefore the total number of ways will be derived from multiplying both the stages. So 45 into 24, the result will be 1080. So 1080 is definitely greater than 1000 or at least 1000. So the best option we have to select is 1 option. So 66 first part is the right answer. In the first concept part, we are going to talk about when to add and when to multiply, the major problem faced by most of the students, and it's very basic. So before we talk about when to add and when to multiply, I'll focus you on the principles which apply to counting. There are 2 principles. One is called rule of sum, the other is called rule of product. Now let's see what's rule of sum. Let's take a scenario that you have 5 long sleeve shirts and 3 short sleeve shirts, and now you want to wear a shirt. So how many options you have? You have either you are going to wear long sleeve or short sleeve, and 5 options in long sleeve and 3 options in short sleeves. It means that either long sleeve or short sleeve. So the word here is or. So you have a choice. So you are going to add 5 plus 3 equals 8. Now coming to the second part, the rule of product. Let's say the same scenario with a little twist, that I have 5 shirts and 3 trousers. Now remember, long sleeve shirts or short sleeve shirts. In that scenario you are going to wear one of the two, but here the category is shirts and trousers, which are always worn in complementary with each other. So you cannot wear shirt or trouser, but you have to wear shirt and trouser. So the number of options you have for wearing the shirt is 5, and the number of options you have to wear trousers is 3. So you are going to choose any of the shirt in 5 ways, and the word here comes and 3 trousers. So every shirt has 3 trousers options. Let's say you have 5 shirts, 5 different colors. Every color has 3 trousers. It can be worn with 3 trousers. So all the 5 shirts had 3 choices. The answer is going to be 5 into 3, 15. So when the word is there or, or there is a cases we add when there is a things in we are doing in stages, or the word is and we multiply. Well, that was very easy to understand. Let's take one more example to get a greater grip of the concept. This is the roadmap to go from city A to city C via city B. As you can see, from A to B there are 2 green roads, and from B to C there are 3 black roads. Now for reaching, it's simple that we have to go to A to B and B to C, and that makes it 2 into 3, that is 6. Even if you focus that okay, I take one of the road from A to B, then I will have 3 choices, and then again if I take the road 2, then still I have 3 choices. That makes it 3 plus 3 equals 6. So yes, we can say that in cases of and, we have to multiply. Let's create one direct flight from A to C. Now creating this direct flight, so this flight, this path is our flight. So as in the previous case, we knew that there are 6 ways, there are 6 roadways to reach. Now we have one more option, that flight way. So we are going to do either roadways or airways. So or word has been replaced by plus. So the total number of ways is going to be 2 into 3 plus 1 equals 7. So concluding, when cases are there, we add. When stages are there, we multiply. When we use the word or, we add. When we use the word and, we multiply. Now moving to the concept 2. In this concept, we are going to talk about 3 most basic techniques of counting. We call the first technique as selection technique, the second technique as shuffling technique, and the third technique as box and letters technique. Let's see individually what are these techniques. Now in selection technique, we are going to select objects from 3 scenarios, that one, a bag of distinct objects, another, a bag of identical objects, a bag of mixed collection. A bag of distinct objects, as you can see, there are distinct objects A, B, C, D, E, F, G. Their distinctness are shown by the color as well. Now let's say we have to select 3 objects. Well, it is a very direct question. The number of ways is going to be 7, choose 3, that is 7C3. Now in the second scenario, let's say you have a bag of identical objects. Let's say you have all the 7 chocolates of the same brand and the same category. So you have to select 4 chocolates out of these 7 identical chocolates. How you are going to do? You are just going to do, it doesn't matter which 4 you are going to select. So the number of ways is always going to be 1. Now coming to the mixed bag collection, when you open a refrigerator, you see 2 Cadbury, 3 Bourbon, 2 another Cadbury, D, E, F. So you have 10 chocolates, but 2 are of same category, 3 are identical, then 2 are identical, and then you have distinct D, E, F. Now you have to select 3 objects. Now this is tricky. So let's break things in cases. Now selecting 3 objects from this mixed bag. So how you are going to attack? We are first going to categorize the selection in terms of like and distinct objects. So for that, we have to break things into cases. So we will have case 1, we will have case 2, we will have case 3. Let's see what we have in case 1. In case 1, we have to take all distinct objects. So whatever 3 chocolates I am going to select, it all has to be different. And in case 2, if I am selecting 3 chocolates, I'll be taking 2 of same category and 1 distinct. And the third case, that I will be selecting all the identical chocolates. I'll be taking only 1 category of chocolate. Now, as we can see, the variety, you have only 6 variety. A, B, C, D, E, and F. Now from 6 variety, I have to choose 3. 1 from each. So the answer is very direct. It's going to be 6C3. In the second scenario, if you have to select 2 identical and 1 distinct, this would be done in stages. First, we have to select 2 identical and we have to select 1 distinct. So and, as we know, will be replaced by multiplication. Now let's say how many categories will be able to actually give me 2 same chocolates. It would be either A or B or C. So from these 3 categories, I just have to choose 1 category. So that would be done in 3C1. Now I have to select 1 distinct objects. So for choosing 1 distinct objects, How many categories I have? As we know, we have total 6 categories. Out of 6 categories, we already had 3 categories for which we could have easily taken 2. So out of 3, we have exhausted 1. So we are left with only 5 categories. And in this 5 category, we just have to choose 1. So that would be done in 5C1. So case 2 would be done in 3C1 and 5C1, which means 3C1 into 5C1. Now, going into the case 3 part, we have to select all the identical. So all 3 identical chocolates, A cannot give me all 3 identicals because A only has 2, C cannot give me, it has only 2, D, E, F has only single chocolates. So only B category has the potential to give me all the 3 chocolates which are identical. So the answer is going to be 1. So the total number of phases, since things are in cases, as we have understood that in cases we add, so the total number of phases is going to be 6C3 plus 3C1 into 5C1 plus 1. Now moving to the shuffling technique, we'll be doing the shuffling of objects, and again we will have 3 scenarios: a bag of distinct objects, a bag of identical objects, and a bag of mixed collection. Now shuffling means changing the pattern of arrangements. Now if you see, if I shuffle A, B, C, D, E, F, G, which all the 7s are distinct, then they will have different shuffling arrangements where we'll be using the concept of permutation. We'll be shuffling it. So the answer is going to be very easy. That is 7 into 6 into 5 into 4 into 3 into 2 into 1, which equates to 7 factorial. Now coming to the second scenario, a bag of identical objects. You all have 7 same chocolates. Now we are going to shuffle them. No matter how many times we shuffle, they will always appear in the same pattern. So answer is going to be 1. Now in the mixed collection, if you see, you have total 10 chocolates, out of which 2 A's, 3 B's, 2 C's, and then D, E, F. Now shuffling 10 chocolates, the answer is going to be 10 factorial upon 2 factorial upon 3 factorial upon 2 factorial. Let's see how. Let's begin our shuffling. In the shuffling of this, first we'll consider all to be distinct. So we'll make A as 2 A's as A1, A2, B as B1, B2, B3, C as C1, C2, D, E, F. So all 10 distincts would be shuffled in 10 factorial ways. That's very clear. Now, since whatever the arrangement we get, it will always be in 10 factorial, but there would be some mistake that no matter what arrangement, if we do the intershuffling of A with A1 with A2, the pattern that won't change. So that could be done in 2 factorial ways. The same things with B1, B2, B3, this can be done in 3 factorials and the pattern won't be affected. And this can be done with C1 and C2 again with 2 factorial. So B can shuffle 3 factorial without changing the arrangement. C can shuffle 2 factorial without changing the pattern, and same A can shuffle 2% but won't change the arrangement, since they are alike. So the total effective number of distinct arrangement would be corrected by 10 factorial divided by 2 factorial, 3 factorial, 2 factorial. Now the third technique, box and letter technique. In box and letter technique, what we have to do, counting the number of arrangements to be done when we have to fit one type of objects in another type. Out of the 2 types, one is shareable, means it can accommodate more than one of the other type, and the other type is unshareable, which means it cannot go to 2 things at the same time. Let's see what does it mean. Let's take an example. Example is letter and letter boxes. Letters are considered to be unshareable and boxes are considered to be shareable. Why? Because in boxes I can insert as many letters as I want, but one letter cannot be inserted in 2 or 3 boxes. So one letter is unshareable, letter boxes are shareable, which means letter box can accommodate more than one letter at the same time, but one letter cannot go into 2 boxes at the same time. Other examples, what you can think of guests and hotels. Let's try to decode what we meant by box and letter technique. Let's say you have 4 letters and 4 envelopes. As we know, one letter can be gone in one envelope only, and no 2 letters can be fitted inside in envelopes. So envelopes is also unshareable, letter is also unshareable. These type of question is a very basic question and the answer is going to be 4 factorial. So this is not what we are talking about. Now let's change the scenario. Let's say we have to post 4 letters into 4 letter boxes. Here we know 4 letter boxes and we know letters are unshareable and boxes are shareable. So total each letter has 4 choices. So letter 1 can go into one of the four boxes, so it has four choice. Letter 2 also has four choice. Letter 3 also has four choice. Letter 4 has also four choice. So the power of choice is with the number of letters. So the answer is going to be 4 to the power 4. Now taking another scenario, that let's say you have to put four letter into three letter boxes. Again, the number of phase, every letter has three options. So first letter can go into three boxes, second letter can go into three boxes, third letter can go into three boxes, fourth letter can go in the four boxes, and all are in stages. So 3 into 3 into 3, that will make it 3 to the power 4. Let's say if there are three letters into four letter boxes, as we know letters are unshareable and boxes are shareable, every letter has four choices. So letter 1 has four choices, letter 2 has four choices, letter 3 has four choices, and all would be done in stages. So it would be 4 into 4 into 4, that is going to be 4 cube. Thus, whenever such question is asked, the number of ways is always going to be shareable to the power unshareable. So in such question, you just have to focus which of the two is shareable and which of the two is unshareable. The one which is shareable needs to be kept in the bracket, and the one which is unshareable needs to be kept at the power, because the power of choices lies with unshareable object, not with the share. Permutation and combination, one of the most difficult topic of mathematics and very tricky in IIT JEE. I have developed this interactive PNC book which will help you conquer the topic with greater understanding. This is the book which talks to you. As you can see, I have given you some insight about what this book looks from inside. As you can see, there are different pages I have taken, and as you see, this book is totally talking to you and trying to make you understand the concept in a better, in a more concrete way. So for free PDF, download this book from the link given in the description.